KitKat on a Galaxy Nexus.
So who are you?
Hey, I'm Khasim. I work as Android Tech Lead at Linaro.
So Android Tech Lead at Linaro, and yesterday what happened?
Oh, we were surprised to see Android 4.4 getting released, and we were actually waiting for buying the devices, and within an hour we found that all devices are sold and we don't have any devices.
You were too busy coding, and then this device got sold out?
Yeah, we were actually completely busy in actually finding out like when the sources are going to be released, and by the time we actually found like all the devices are out, so we actually went and bought this KitKat.
What do you do? What are you doing on this laptop right now?
Right now,
Yeah.
there's an interesting thing going on here, which is building a version of Android 4.4 that will in the end run on a Galaxy Nexus. So if we can't get a Nexus 5, we just have to backport the interesting things to other devices.
So you're doing that right now, and so
Yeah.
do you have some like overview already of what 4.4 does?
Yeah, so yesterday we started pulling the sources and started analyzing the sources and finding out like what has changed. So we quite a lot, like 4.4 is bringing in so many new features, and one interesting thing that I found is like now they are actually allowing printing of Google Docs, like the documents that you have over cloud, you can print it over Wi-Fi and Bluetooth. That's really amazing thing. And then from the actually core Android point of view, the hardware composer is actually changing to version 1.3, and that will give you like good on the display rendering and things. Surface Flinger is changing to OpenGL ES 3.0, so the rendering will be much more smooth. And with the hardware composer 1.3, you will get virtual displays. Like earlier it was only primary display, now you would get secondary display like HDMI or something. The other thing I found was they have added this IR functionality, which is called the IR Blaster. This, I think they have done this for mainly for this Chromecast kind of applications where you can actually control your devices.
Android TV.
Yeah, Android TV and so kind of application. So that's one interesting thing. And a lot of sensor support has been added, like geomagnetic sensors, step control, step counters, sensors. All these features have been added now. The other interesting thing I found was all the applications that you have now, you can have multiple applications for same feature, same functionality, and by default you can choose in the developer options like which you want to use. And for example, if you want to choose a particular SMS messaging application, so that will be your default app, and the interrupts and the notifications won't go to other applications, so thereby the performance is going to be much more smoother, I believe.
Nice. And there's also a whole bunch of things with art, right? What is art?
He is good on art. So
what is art?
So art is, to me, it's actually the most interesting feature in 4.4, but it's hidden away. By default, if you just look at a 4.4 device, you're not going to see it. It's a complete replacement of the virtual machine that's running Java applications on Android. This used to be Dalvik, and now they're starting to push art. In 4.4, art is included as a development preview, and in order to activate it, you have to enter development mode by going to settings, about phone, and tapping the build number a couple of times. And then you get an option in a developer menu that allows you to pick a virtual machine. And by default, it's still Dalvik, but you can switch over to art, which should be much faster, and is just a much cleaner code base, so that's just going to be where the future is.
So it's rebuilt from scratch? It's redone from scratch, the virtual machine?
Yeah, it looks like someone took it and thought, okay, what was wrong with Dalvik and how would we do it if we were starting from scratch, and then did just that.
And that's the main reason it works on cheaper phones?
Probably. There's also a couple of other modifications, like improvements in Bionic, but well, actually those other improvements really have to be the key things, because as we mentioned before, art isn't enabled by default, but art is definitely going to help there as well. Basically, art supports pre-compiling stuff to native code, so you don't have the performance overhead of a virtual machine translating stuff.
Nice. All right.
Also for low-end entry devices, we also met few Google guys, like they were saying that there is a lot of optimization done on memory, like memory optimizations done for low-end and the entry-level devices. So I'm not aware like how much of the memory optimization is done. When we read the code more, we might be able to see like what all things has been done. The connectivity side, like the interesting part is like they have added this Bluetooth HID over GAT, which is more of like gives you connecting joysticks and like mouse and joysticks and so on, all these HID devices for low power. So that is going to be interesting. So I'm more worried now, like the kind of markets that actually this will enable and penetrate into, like the kind of the HID, the Wi-Fi direct streaming if you are on the same network, so you can stream between devices, and the Bluetooth features and so on. So the phone will be definitely now moving towards completely different usage and functionality, I believe. So
what's in there with the wearable computing? Is there something you've noticed?
Actually, I didn't find anything on wearable computing. That's interesting. But then the other thing, like as I said, like on the Bluetooth side, we see quite a few things added. So like there is also this MAP protocol that is given, message access protocol, which is the new profile that has been added. Maybe that could be used for all these wearable computing.
Maybe it will only get released when this Google Watch is released, right? They only might release later, the wearable part.
Yes, actually I think one of the things why they are pushing 4.4 on the wearable parts is because it's much more friendly to devices that have low memory. So probably all the interesting code for that is already in there. It's just not, at least not officially being used to build wearable devices yet.
So it's 9 o'clock here in the morning, so you didn't sleep so much, right?
No, I spent pretty much all night rebasing our patches to the 4.4 code base and trying to get it to run on older devices such as the Galaxy Nexus.
So
well, right now,
what does that mean?
Right now the build is still running, so we don't really know whether this is going to work. But if it works, we just have a build of Android 4.4 that runs on older devices, and we don't have to wait for the Nexus 5 to just get some more experience with it.
So what does that mean? Does that mean you're trying to upgrade, put your patches automatically, and the places where it doesn't work out, you need to figure out why it didn't work out and fix that? And is that what you did all night? Yes.
I have a nice script that just goes into AOSP sources, pulls the new tags like Android-4.4_R1, and then tries to rebase all the Linaro specific patches to it. And for all the repositories where those merges work automatically, where nothing related has changed upstream, it just creates the Linaro Android 4.4 tag, and essentially we don't need to do anything else there. And for projects where patch merging fails, it just dumps me a list of projects where I need to go see why it failed, what changed, and how the patch has to be redone. For the 4.4 release, this happened in 28 subdirectories, which is actually not so bad given what a major release this seems to be. Yeah, also just being able to at least get it to a point where the patches look good within a night is more proof of that.
Does that mean that you did those 28 fixes overnight?
Yes.
So the 28 parts that didn't work, you went and you fixed each of them already?
I fixed the patch application, and there's a pretty good chance there will still be some issue that needs to be fixed that will only be detected at compile time or even at runtime.
When do you know when that is? How long time and more do you need to know? Takes a while?
Probably not that much longer. It's been compiling for like 3 hours now.
Okay.
Actually, I see the build just failed. Error initializing argument 1. But this is not actually so bad. That's a compile time error that can be fixed with modifying one line of code.
Oh yeah.
So it will require a little bit more tweaking, but in the end, I hope to have a working build later today. But one of the bigger problems is one of the changes that have been made in 4.4 is upgrading to the new hardware composer, switching Surface Flinger over from OpenGLES 1.1 or 1.2 to 2.0, which might just break the binary drivers that have been released with older devices. And we don't have the source for those drivers, so fixing those is hard to impossible. But in the worst case, we will just have to disable hardware acceleration for the time being and just use CPU-based rendering, which is slow, but which should help get us going until graphics drivers for 4.4 are released.
So the graphics drivers are not released because it's Snapdragon 800? Or why?
Yeah, so far the only device officially supported by 4.4 is the Nexus 5, which is a Snapdragon 800. So any device that is using a GPU that is different from the Adreno that's being used there may or may not work. We have to see whether or not there's any compatibility code that lets old drivers continue to work.
What else is the challenge for the next few days?
Well, there's going to be, or at least there might be, some more compile time failures like this, just caused by us using a different compiler. And there will probably be some runtime issues related to the fact that 4.4 just hasn't been tested on the devices we want to run it on. So,
are you going to make 4.4 better? A lot better? What are you going to do?
We'll have to see, but there's several things that we are planning to do. And first of all, we're going to rebase the Linaro patches that have gone into all the older releases, like optimized memory handling, and we will also introduce 64-bit memory handling patches. And another interesting thing that is currently going on is work on building Android with a completely different toolchain. Right now, Android is using what you'd find on pretty much every Linux system, binutils and GCC. And there's work going on replacing that with LLVM and Clang, which is interesting primarily because Clang has pretty good support for compiling stuff that will run on a GPU instead of a CPU, and because Android already uses LLVM and Clang for things like RenderScript, and it doesn't really make sense to use two different toolchains if you have to use one anyway. So another thing that's going to happen next week, we have already done some work on that. We have 4.3 compiling but not quite booting yet with LLVM and Clang-based toolchain. And we are going to rebase those patches to 4.4 and then going to immediately submit them upstream so Google can continue our work, and of course we will continue our work as well.
What's 64-bit in 4.4? Is there any 64-bit yet by Google, or can you see it?
So far I haven't really looked for it because my main interest has been getting it just running on any device I already have, and 64-bit ARM devices just don't exist yet. So I'm going to look into that later, but I think from what I've heard there's going to be some support for it already.
Cool. But there's no desktop mode, laptop mode, or e-reader mode. For now we don't see that. It's not in the Nexus 5 code, right?
No. But I think eventually that's going to happen with those mobile CPUs becoming stronger and stronger. I think at some point we will have a device that essentially is your phone, and then you plug in your screen and a keyboard, it becomes your desktop, which will probably be sufficient for most people, not for everyone, because I can't really imagine compiling the entire Android source tree on a phone, but I think this will definitely be interesting in the future.
So only when you compile you can use your x86 or something else server.
Yeah.
Otherwise, you could do everything else.
Yes. In a way, people are already doing that when they're using, for example, a Chromebook, or when they're editing documents on their phone, or when they use Linaro builds on their phone. They can even have GCC on their phone and compile simple things.
Because would you want to swap this out, this HP out, with a ARM-powered HP?
That would be fun. I think right now we are just not at a point where this is feasible, because I have to do some fairly CPU-intensive things. But with ARC64 coming up and some promises of real speed improvements there, this should become an option soon, and this will be really interesting.
Cool. It could be right here. You can hold this 1 second. Yeah. right here. There. There, you can switch to this one. If you want.
Ah, this is nice. Is this a new ARM Chromebook?
Yeah.
I've seen one before, but that was a different type.
This is the HP. Alright. But we need octa-core in there, right? There's only dual core.
Yeah, that would be really good. So those things will already be good enough for what many people do, especially when you put on a real version of Linux. Chrome OS is interesting if you want to browse the web, but it's not really that suitable for doing any offline work. Like I wouldn't want to use this in the stock operating system while on a plane.
Alright.
But at least for the previous Chromebook, hacks were released that would allow you to install a full regular Linux on it, including even running LibreOffice on it.
Cool.
So those devices are certainly interesting.
Cool. Let's do more videos later.
Yeah.
So here, this after the session, like half an hour later, what happens? What have you been doing since?
Yeah, so I fixed a problem we were facing earlier, which turned out to be caused by just not having the right compiler flags in there. Some new code started setting the CPP flags to -std equals GNU ++11, and a couple of lines later we were adding -f no strict aliasing by redefining that variable instead of just adding to it. This was okay in earlier releases because the variable was blank and there wasn't anything in there, but now we had to change that equal to a plus equal. Now that's gone, but we are already seeing the next thing here.
What is that?
This is one of the things that -f no strict aliasing is going to fix. Let me just do that.
You just do it?
Yes. Okay, that error is gone. Now it can continue compiling.
So you just fixed one thing
Yeah.
out of the 28 or what? What is that?
Now the 28 things are already fixed. Those were merge conflicts that could be detected, and now I'm trying to build the entire thing. And, there will be some problems caused by stuff that can't be detected automatically. For example, setting a variable instead of adding to it, because now that variable is being set by upstream. And we will probably see some more of those before it really finishes compiling, and before we can actually do this KitKat on a Galaxy Nexus.
So just before the beginning of the video, your colleague, what's his name?
Khasim?
Khasim, he had the top 10, right?
Yeah.
Could you go deeper into some of those? So which one was over there?
Yeah. I think most of them we already covered. To me, the most interesting thing is art. Another thing that actually hasn't been on the list, but that is quite interesting, is that all the web browsing stuff has been replaced. Probably most people who are using an Android device that is not running stock AOSP will be using the Chrome browser anyway. But now Android always used to have a small browser application that was just based on WebKit, and that was getting really outdated. In fact, in my Connect session on Tuesday about Android upstreams, one of the things I was complaining about was that this WebKit version is just horribly outdated and need to be synced. And now, looking at the KitKat source, that old browser application is gone, the external /WebKit subdirectory is gone, and instead Chromium has started to drop in, so it looks like even when we're not installing any binary stuff like Chrome, we're going to have a decent default browser these days.
The trick is, do they have Flash support?
Probably not, but who cares about Flash support these days? HTML5 has come a long way.
Because, what's it called, Chrome OS has Flash support, and it's on ARM. So why can't we have a full Chrome browser on Android? The same as in Chrome OS?
We could, but Flash is not open source, and we shouldn't be using closed components, especially not components that are known to have security issues that need to be fixed every other day. So the earlier flash dies, the better.
All right.
And actually, there's a project called Gnash, which replaces flash with a completely free thing. That is unfortunately not 100% running on Android, but sometime it will get there, and it's a much better alternative to that stupid flash plugin.
Right. So, what is going on there? You just wait?
Yes, no, I'm just waiting for the compiler to build everything it can build and let me know if there's any other problem.
How long will it take?
That is hard to tell because so far I haven't been able to build 4.4, but if 4.3 is any indication on this particular hardware build, it should take around 6 hours. And around 3 hours have already passed, so...
So in 3 hours you'll get closer to what?
Well, assuming there's no other compile time bug in there, which may or may not be a correct assumption, but if there's no more compile time bugs in about 3 hours, we'll have an image that is based on 4.4 with the Galaxy Nexus driver, and then we can try actually installing it on a piece of hardware to see if it boots and if it works.
On the Galaxy Nexus?
Yes.
So let's see, check it out. Maybe in 3 hours you have it working on the Galaxy Nexus.
Yes, there's a pretty good chance that it's not going to work immediately because of the graphics driver issues we've discussed before. But if we're lucky, we'll have 4.4 on Galaxy Nexus and soon on other devices.
Which other devices?
All the devices supported in Linaro builds, which is some development boards including Panda and Armdale, and also a lot of other Nexus devices.
So it's OMAP 4, it's Exynos 5, it's what?
Essentially OMAP 4 and Nexus 5 are the important ones, because those chips come out of Linaro member companies, and those chipsets are really what we should be supporting. But the Nexus devices are also interesting to us regardless of what chipset is in them, just because they are what makes it easiest to work with upstream AOSP. So once we have all the other things going, we will probably put out builds for Nexus 7 and Nexus 4.
Would it be cool if Qualcomm was part of Linaro?
Of course. As many members as we can get would be nice, and Qualcomm has some really interesting technology, and it would be really good to be working on the same devices that AOSP Upstream is working on, most of which currently seem to be Qualcomm based.
Cool. Okay, but let's make some videos later when this is working.
Yes.
On the Nexus Galaxy.
So far this is making some progress, not erroring out, but that is expected. Usually there's just lots of waiting for the compiler on a relatively slow machine like this one.
Are you doing this remotely?
No, this is just running directly here. I don't want to use up the entire internet connection here.
Alright, cool. Okay, we'll see you later.